Hey guys, welcome back to chemistry. This is going to be lesson 1, basic ionic chemical formulas. So I'm going to go over today how we're going to use our periodic table. So you'll need this, go ahead and get that out. How we can use our periodic table to create basic ionic chemical formulas. Okay, so the first thing that we need to know here is that we need to use oxidation numbers. Okay, and if you remember from what we did the first day of term 7, is we reviewed the oxidation number trend across the periodic table. Okay, remember everything in that first column is going to be +1 when it becomes an ion. Everything in the second column will become +2. The transition metals are variable, and I'll get to that in another lesson. Okay, this third column by and large is going to be always +3. I'm going to have you skip the carbon family because they can have charge, but they also can be covalently bonded, so they're kind of a special case. Now the nitrogen family, these guys are going to be -3. The oxygen family will be -2. The fluorine family will be 1. And remember, our noble gases have no charge because they are inert. They, by and large, don't give up, share any of their electrons. Okay, so we have +1, +2, +3, skip -3, -2, -1. Okay, so we're going to be using those to create our formulas. Okay, for your formulas, our basic ones at least, we're going to have 2 elements. Okay, and you're going to have a cation, remember, which is positive, and these are our metals. And we're going to have an anion, which are negative, and these are our nonmetals. You always write the cation first, and then the anion. That is the accepted way for chemists all over the world to create these formulas. If you use the anion, put the anion first, it is technically wrong. So please make sure you're putting your metals or your cations first, okay? So let's go ahead and get started. You do need to remember that formulas are they are electrically neutral. Did I spell that correct? Anywho, it means that you need to have the same number of positive and negative charges. You want to have a net charge of 0, okay? The reason why elements will come together to create a chemical bond, to create a formula, to create something, is to balance out their charges. They want to be stable. They want to be electrically neutral. They don't want to be in this ionic, they don't want to be ions. They don't want to be charged. They want to come together and be neutral. All right, so we're always aiming for this, this net 0 charge. Okay, so our first example, all right, let's do the classic sodium chloride. So we have Na and we have Cl. Now, sodium is a metal, all right, that is our cation. It is going to be named first, and it carries with it a +1 charge. So I'm going to put +1 right there. Chlorine is over here. It is a nonmetal, and it's going to be a -1 charge. So I'm going to put -1 right there. Okay. So what I do here is I keep a tally of the positive and negative charges. This is +1. This is -1. +1 -1 is equal. Is net 0. Net 0 charge. So once you get to this net 0 charge, you can just stop. You don't need to add any more sodiums or chlorines because their charges equal out. +1 -1. Okay. So once you figure out that it's net 0 charge, all you do is you look at how many you have. So over here, we have 1 sodium, 1 chlorine. Okay, it's important that the first letter is capitalized and the second letter is not capitalized as it showed on the periodic table, that is an issue. Because over here you see cobalt, capital C, little o. If you put capital C, capital O, that's carbon monoxide, and that's a whole different compound than cobalt. So please make sure you're careful when you're writing these. Okay, so this is our first formula. Okay, we have one sodium, so we only have one sodium here. We have one chlorine, so we have one chlorine here. Okay, let's see, this is example 1. Let's do example 2. Okay, so let's go ahead and do calcium. So calcium, all right, is a +2 ion, or with the oxidation number +2. All right, and let's go ahead and do fluorine. Okay, fluorine, again, has a -1 charge right here, so I'm going to put -1 right there. Okay, so let me delineate this. We have +2 -1. That is a +1 charge. That is not electrically neutral. So we're going to have to add something to try to neutralize this charge, okay? We can't take away from calcium, but we can add another fluorine. So I'm going to add one more fluorine here. All right, so +2 stays the same. -1, -1 is -2. All right, +2, -2. There's our net zero charge. All right, so now I'm just going to, once I figured out the charges, you don't worry about them anymore, okay? You go ahead and just count how many you have. We have 1 calcium, so I'm going to put Ca for calcium, and we have 2 fluorines this time. So I'm going to write fluorine, but I put a subscript of 2. That tells me I have 2 fluorine atoms in that compound. And notice, guys, when I'm writing my formulas, there are no charges. There are no charges in these formulas at all. All right, you just have how many atoms there are. So over here, again, we have 1 sodium and 1 chlorine. So again, this is implied. This would be like an implied one, and this would be an implied one down here, but because it's already there, you don't have to write a 1. So this is sodium, 1 sodium, 1 chlorine. Over here, we have 1 calcium. Again, it's an implied one. And then we have 2 fluorines, which is why we put that subscript 2, because that's how many atoms we actually have. Once you balance the charges, leave them off of your final formula. Okay, let's keep doing a few more. All right. Example 3. Let's go ahead and do potassium and oxygen. All right, so go ahead and pause your video and do this really quickly to see if you can get it before I do this, so you know if you're understanding the concept. So go ahead and pause it, look up the oxidation numbers, try to balance it out and create your formula. Go ahead and pause it now. I'm assuming that you did that. And if you look over here on the periodic table, we have potassium, which is +1. So I'm going to put +1 right there. Oxygen, which is -2. I'll put -2 here. All right. So if we looked at our charges, and I guess I'll use a pencil for this since it's a better thing to do, since I can erase, we have +1, oh, great, +1, and then -2. That's going to net, oh, you can barely see that. Okay, well, never mind. +1, -2, and that net is going to be what? -1. That is not electrically neutral. So we're going to, we can't take away from oxygen. We can add another potassium. So let's add another potassium. That's +1 plus +1 is +2 now. +2 -2. Now we have our net zero. So do you see what I'm doing? I'm balancing out the charges to make the whole unit electrically neutral. That's why they come together to create these compounds, okay? So now that it's electrically neutral, we can go ahead and count how many atoms we have. We have 2 potassium, so I'm going to put K and then put a subscript of 2. And we have 1 oxygen, so I'm just going to write the O. That's potassium oxide. Again, notice there are no charges. Just the subscripts represent how many I have over here that it took to get to the neutral point. Okay? Let's do another example. All right, let's go ahead and do beryllium and sulfur. Beryllium has a +2 charge, and sulfur has a -2 charge. So look at that. Super duper easy now. +2, -2, electrically neutral. We are good. We have one beryllium, so we just put Be, an implied one, and then we have one sulfur. This would be beryllium sulfide. Okay, let's do another example. Example 5. Let's go ahead and do aluminum now. Aluminum, and let's do bromine. All right, aluminum and bromine. Go ahead and pause your video and see if you can do this on your own. I'm going to assume that you did that. So let's look. Aluminum is +3, and bromine is -1. So again, +3 -1, that's +2, that is not electrically neutral, right? So again, we can't take that away, but we can add some more of these guys. So we can add 2 more bromines. All right, so we have +3 plus -1, -1, -1, which together is -3. And now, +3 -3, that is electrically neutral. So again, we have 1 aluminum, and now we have 3 bromines, so Br and then subscript 3. Aluminum bromide. Is it making sense so far, guys? I hope so. All right, let's do another example. That's 5. All right, so let's do example 6 right here, okay? Let's go ahead and do aluminum and oxygen. So we do aluminum and oxygen. Now we know from the last example, aluminum is +3. Oxygen is -2. All right. Now, if you're asking, okay, well, there's no 1 in there, it makes it harder to balance. Think about it this way. What is the most common denominator between 2 and 3? If you answered 6, you're right. So when you see 2 and 3 or 3 and 2, you're going to want to try to get a denominator of 6. So down here, you're going to want to get a +6 and a -6 to get neutral. And now we just kind of work backwards. So we need 1 more aluminum to be +3 +3 to get +6. And we're going to need 2 more oxygen to get -2, -2, -2 to get -6. Okay, so just word to the wise, anytime you see 3 or 2, or a 2 and a 3, you're going to want to get a denominator of 6. Okay, so now that that's balanced, again, we just count how many we have. We drop the charges now, we just count. So we have 2 aluminum, so this is going to be Al subscript 2, and then 3 oxygen, so O3. And that is aluminum oxide. So far, so good, guys? All right, so you guys are going to be doing this for your first assignment. So make sure you have your periodic table and make sure you have your oxidation numbers, okay? And you're going to be showing me this work, the work that I showed you here. What you guys are going to see is this. Now, if you notice that for this worksheet, it's basically the same thing. I did that so that when I was printing them, I could print 2 to a page and save paper. Doesn't really help you when it's in a PDF format. So ignore one of them. It honestly doesn't matter. That is what I would have done anyways. So this will be your first assignment. What I'm going to have you guys do is go through first. Here are your cations. These are all positive, and here are your anions. These will be negative, and you're going to be creating formulas between all of these. You're going to need to show your work the exact way that I showed you. So you're probably going to need to, I would use, either if you don't have a printer, and I understand if you don't, use a full notebook paper. I would turn it on its side, and I would use rulers, all right, to actually create this grid. I would. If you can make it large enough, you can actually show all of your work right on that paper. This is kind of small to show work. I would have had you guys show work on a separate page as well. But go ahead, and if you do it on a full paper like this, using rulers, please be neat. You should be able to show your work on this as well. Box your answer so it's a lot easier for me to see, okay? I normally don't advocate for using, for using pen when we're doing this, but for me to be able to see it on your pictures or your scans, pen will show up easier for me to be able to grade. Try to use a pen if you can, all right? And just use some whiteout or something like that if you need to, if you make a mistake. So what you're going to do across the top is you're going to write down the oxidation numbers. Nitrogen is -3, oxygen is -2, fluorine is -1. And notice this, these are superscripts. These go up top. Selenium is right here, so that's -2. All right, so you keep going across, and now you go down. Hydrogen is +1. Magnesium is +2. Potassium is +1. Aluminum is +3. Do you see what I'm doing, guys? And then you're going to go ahead and you're going to create your formulas. Remember, cations are always written first, then the anions. So show me your work, please. Show me your work. So here, right here, H and then O, we have H +1, O -2. We know we're going to need 2 of these guys. I'm sorry. So this is going to be +2, -2. That's neutral. H2O, my loves. There you go. Do you see what I'm saying? So if you can make this a little bit larger to show me your work and then box your answer, we are good. Okay. Same thing here. You put your cation first, your anion over here, +1, -1 equals 0. This is HF, and this is hydrofluoric acid. That's some nasty stuff. You do not want to get that on your skin. Okay. So I want you guys to go through and create all of these formulas. I figure with copying it down onto a paper and then actually doing it, it should take you about 2 days of 2.5 hours. This I will expect to be due on Friday. So I would like you guys to take a picture or scan it with your, I don't know if you have an app on your phone, and I would like you to have this submitted into class by 9 a.m. on Friday. Okay, Friday, May 10th. Okay, Friday, May 10th. So please do that. I will be checking work, so make sure you are doing this on time. And I will be available via Zoom during our Science 1 time if you have any questions or you need any help. Okay. All right. I hope this was clear. If there's anything I can do better, please let me know. I'm trying to do my best with the constraints that I have. Good luck. Good luck. And I will see you soon. Bye, sweeties.